Welcome back. Today we're going to talk about the four-step process for finding um, confidence intervals for means. And what we've been really using as our example has been that notion of we have data that falls into the category of mean. So whether that's a test score or a height or the number of states that you can remember in a certain amount of time, that's kind of what we're operating on. The cool thing about what we're going to be doing with this type of information is going to look very, very familiar to what we did when we were dealing with proportions. So there's still going to be four steps. Let me wand over here. So four steps. Oops. Four steps. I can zoom in a little bit here. There's going to be four steps. And we're going to have our statements. And what we're going to state is that our mu is our true mean. Okay. And in our plan, for now, what we're going to be working with is one sample. So we're going to have one sample, and it's going to be a t interval. So we're going to be doing a one sample t interval for mu, for our true mean. And what we're going to be doing is we're going to be assessing, obviously, our conditions, but the normality of the situation. And if you recall, what we've talked about before is when we're dealing with means, we can look at our distribution and we can do, say, a couple of different things. Either our population is normal, or we can use our central limit theorem where our n is greater than or equal to 30. And if we remember what CLT, central limit theorem, so central limit theorem would apply there. Or when we map out our sample can show no skew or strong outliers. So sample shows no strong skew or outliers. So that's kind of our assessment of normal. And what we're going to do is going to look very familiar. Check this out. Our do is going to be our sample mean, or our x bar, plus or minus. Let me make that a little bit more clear. Let's see. Erase that. So x bar plus or minus our t star times our standard deviation over the square root of our sample size, which is n. And for this one, in our conclusion, these are baby steps in the direction of doing our actual inference test. So these are going to be baby steps in making this conclusion. Whoops. Okay, let me zoom out there. Okay, so that's our first part, our basic first part. Now, second part, determining sample size or using sample size to actually do these calculations. So here we go, sample size. Our margin of error now obviously, so you're gonna think this is just redundant, right? Because we've kind of done this before, or if you don't think that it's redundant, this is a good time to kind of hammer in on this concept of what is our margin of error. Our margin of error is this piece here that we're doing the plus or minus. So it's the t star times the standard deviation over our sample size. And that's in our previous formula was what was plus or minus. So we're going to have that x bar, and that x bar is going to be our critical value. And no, sorry, the x bar is going to be our point estimate, and then our t star is our critical value times our standard deviation over, factoring in our sample size, or standard deviation factoring our sample size. That's our margin of error. And there's going to come times in this example that we're just about to do, right, where we don't know what the t star is, and they're going to ask us to construct a confidence interval. And so we are going to use z star in place of t star if it's unknown. So if we don't know it, so if t star is unknown, we're going to use z star in place of t star. Okay. So here we go. Let's do an example. In this example, administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicated that the standard deviation of time spent on homework is about 154 minutes. How many students need to be surveyed to meet the administrator's goal? So this is one of those questions that we've encountered before where we're actually going to have to work backwards, right? Because they're asking us how many students, and how many students is an n question mark question. Like, we don't know how many students that is. But what we do know is they want to estimate at the 90% confidence level with a margin of error of at most 30 minutes. So our margin of error is going to be equal to 30. And like we discussed up above, 30 as the margin of error is equal to our t star times our standard deviation over the square root of our total number of people, so our n. What pieces do we know? Well, we obviously know the 30. And it's said in here that we know that 154 minutes is our standard deviation. And then on the bottom, we don't know square root of n, but we also don't know, kind of got ahead of myself there, give me a second. We also don't know our t star. Well, we don't know our t star, but in the absence of a t star, we can use our z star level for 90%. And our z star level for 90% is 1.645. And so our z star level of 1.645 would mean that when we set up our equation, check this out, 30 is equal to t star, oops, that's what I just told you. We're going to use 1.645 times, and up top we're going to have our standard deviation of 154 over the square root of n, which was what we don't know. And when you do the mathematics to rearrange everything, we're going to end up with the square root of n squared is equal to 1.645 times 154 over 30 squared. And remember, we want to round up, so if n is equal to 71.31, which is what you'd get when you did this, we need n is equal to 72 students. Okay? And I breezed over a little bit of the math there, but that's kind of those algebraic manipulations. The important part for us as AP Stat students is to understand like what they're asking for, and they're asking us to find that that n from working backwards from that that margin of error formula. Okay, second example. Biologists studying the healing of skin wounds measured the rate at which new cells closed a cut made in the skin of anesthetized newts. Here are data from a random sample of 18 newts measured in micrometers to the millicentimeter per hour. Data. Calculate and interpret a 95% confidence interval for the mean healing rate, mu. So, what are we actually asking here? So they're having us start at the beginning to find this confidence interval. So we're going to go through our four-step process. State. What is it that we're doing? Well, we want to estimate mu, which is the true mean healing time, or healing rate, So SMU, which is the true mean healing rate, at a 95% level. And 95% level is an acceptable way to say that. We don't have to say 95% confidence level. Over here, our plan. Well, what do we have? We have one sample. We have one random sample of 18. And so we're going to do a one sample T and why is it a T interval? Because we are dealing with means here. So it's a one sample T interval for mu, which we defined above. And so then we need to find our condition. So is it random? Yes, it says random right here. Oops. It is random. Okay, erase this little mark over here. You may have noticed that was not the eraser. Okay, so yes, it's random. We need to check our 10% condition so that we can use our standard deviation formula. So 10% condition, we are going to assume that 18 is less than 1/10 or less than 1/10 or less than 1%, less than 10% of all these newts. And we're looking at, is it normal? Is it normal? Well, how do we know? It doesn't state that it's normal. It doesn't state that the population is normal. And so what we're going to have to do is we're going to have to sketch ourselves a little box here. And so here's our frequency. 1, 2, 3. And if we put 10 here, we put 20 here, we put 30, and up to 40. We've got to put our data into some sets here. So let's look at our tens kind of spot here. And we can put our in-between values in here. 15. So 10 to 15, how many in this 10 to 15? So let's see, 1, 2, 3. We are going to need to sketch ourselves a little dot plot here. I kind of see that I've got, let's see, 10, 15, let's make this 10. 25, 30, kind of up to 40. Okay, so 11, 12, 14. So I've got 12, 14. Let's see in order. Let's see, 22, 26, 23, 18. So 18, 22, 23. Got another 22 here. Got another 23. Why am I doing this? What am I looking for? Well, really what I'm looking for is that it didn't say normal. It didn't say over 30. So what I'm looking for is any strong skew or outliers. And I don't anticipate it, right? Because I'm looking at this data. I don't see any particularly big outliers, but let's just look. I got a 29. I got a 27. So I'll cross out 30 because I did that one. Got my 28 in there, 27, 29. And let's see, 34, 35. So I got 34, two 35s, a 40. Okay. Do I have any evidence for outliers? No, that 40 is kind of out there a little bit by itself, but it's not an outlier. So normal, what am I going to say? I'm going to say no strong skew or outliers. Okay. So then what am I doing? I'm going to construct this interval. So under my do, I'm going to put my formula, my point estimate, plus or minus my margin of error. And then I can put down my actual formula, which is going to be my x bar plus or minus t star times the standard deviation over the square root of n. Where am I going to get these values from? Well, guys, look, check it out. I'm going to get my x bar, my standard deviation, and even, the square root of n, obviously we can find that from my list one, and then doing my one variable statistics. Okay, so if I do list one, put all this information in list one, and then do my one bar stats, it's gonna spit out what I want here. And so when I do that, I get that my x bar is 25.67 plus or minus, and what's my t star for this? My t star is 2.110. Remember, we can use our calculator to work backwards, right? Work backwards from our percent level. We can also use our degrees of freedom and get our number there. And then degrees of freedom from table C. So then our standard deviation is 8.32 over the square root of 18. When I actually do this math, I get an interval of, and now, so when you're watching videos, guys, here's a little tip for you. You can pause this right here and try to do these calculations by yourself. Don't get lulled to sleep by thinking, oh, I'm doing it, so, or he's doing it, so I can do it. So actually pause and try to get these calculations. Like when I said, hey, go to your table and get your percent here, or get your t star here. Like actually go to this table. So I've got my stats formula sheet here pulled up, and if I go to my table here, my table B, here I think I misspoke. I think it's the table C. So I can go over to my 18, right? 18 is my degrees of freedom, and I want 90%, 95%, 95%. So 95%. So I want this column here, this 0.025. Remember, that's the tail probability, both tails. So you divide the total percent left over, that 5% divided in half. And I'm going to go to right here. Here it is. 18 is my degrees of freedom, my tail probability. Okay. And so when I grab that, and this should be 101. See there? You can actually find that tail probability. That would be a good step for you to do. Don't fall asleep thinking that I'm doing it so you can just do it right away. So when I calculate this interval, it's 21.83, no, sorry, 53, comma, 29.81. What does this actually mean? So up there I said conclude. None. Well, when we actually have an interval, we can make a conclusion. What is the conclusion? What is the conclusion that we can make? And this is where we're going to make our statistics money, right? So we are 95% confident that the true mean healing rate falls in the interval from 21.53 to 29.81 micrometers per hour. Okay, we are 95% confident that the true mean healing rate falls in the interval from 21.53 to 29.81 micrometers per hour. And we could say healing rate for newts to provide a little bit more context there. That's the basics of it, guys. That should look really, really familiar to you when you're going to do this these intervals, right? So we're using T-star, which comes from table B. We use our degrees of freedom and our confidence level, but really, I mean, this should look very, very familiar to you. And if it doesn't, then this is a good introduction to that, and it's going to be a good review of using proportions and making confidence intervals for proportions. So I hope you learned something, and we'll see you next time.